Okay, so recording has started. So Aniruddha, perhaps what you can do is rather than checking your answer, you can just tell us how you have done this problem so that we will know whether your method is right, wrong, or other people will also benefit from your thought process.
Sure, sir. Sure, sir. So, first, sir, what I did was with the relative humidity given,
Right.
I calculated the partial pressure. First I calculated the vapor pressure.
So from temperature, you
So
calculated
the
vapor
vapor pressure,
pressure.
yes, sir.
Yes, that is already done. Already we have done it in the previous one. So now with 75% humidity, you have calculated the partial
With
pressure.
humidity, partial pressure.
Okay, now
Yes,
let me
sir. So
just
the
write.
partial pressure is,
Yeah, let me just write those values so that it is everybody is aware. So partial pressure was 26.6 mmHg.
yes,
That
sir.
was there in the previous problem. It is the same. Okay, now
Yes, sir. So, first, sir, the mole fraction into the total pressure will give you the partial pressure. So,
correct.
going by that,
Okay,
I got the mole fraction of vapor of water vapor to be 0.0357, the same in the previous problem. So, with the mole fraction of
0.0357.
water,
Okay,
uh, with this mole fraction, sir, because in the question it has been given that 80% has been removed as in content. Yes,
80% has been removed.
yes,
Yes.
so yes, so 80% has been removed. So from this mole fraction, as in because the water is already less in amount, so compared to the dry air, we can
Okay.
say that 20% of this mole fraction will remain um, in the beaker. Yes, sir, again.
Yeah. So
So
what you are
20% of this.
okay. So maybe what you are saying is after
20,
compression,
yes, sir.
after compression. So this was the situation before compression. Compression means
Yes, sir.
increase in pressure. Now after compression, what you are saying is mole fraction. I should not say H2O, I should say water vapor. Okay, now you
Yes,
are saying water vapor would be 20% of this number 0.0357. Is that what you are
yes, sir.
saying?
Yes,
Ah,
sir.
okay, so it is the same thing that who was it? Prajot was doing, is because what Prajot was doing was rather than taking a mole fraction, he was taking basis as dry air, right? Now you are
Understood.
saying that your basis is, let's say, 100 kilomoles or 100, let's say, gram moles of initial mixture, correct? So if you're
Yes, sir.
100 grams of, so let me write this basis rather than writing it here, let me write it here, right? Okay, so basis is 100 gram moles of ambient air. So if it is 100 gram moles of ambient air, this consists of two parts, water vapor and the dry air. So if 100 gram moles of ambient air you are taking, water vapor, based on this mole fraction 0.0357, it would be
3 point.
3.57
Yes,
gram moles of water vapor and 96.43 gram moles of dry air, correct?
yes, sir.
And now you are saying that this air is compressed so as to remove 80% of water vapor. So now we should do after compression. So after compression, we will write here our water vapor and dry air. Dry air will remain the same, 96.43 gram moles. Water vapor will remain 3.57. 80% of that will be condensed. 20% of water vapor will remain. That means water vapor would be zero point 0.2 multiplied by 3.57. This is 0.714 gram moles. Now Aniruddha, do you see your mistake? Now what is the total moles? Total moles is
Yes, sir. The
0.714 plus 96.43. Total moles would be 97.144. Now
there would be a
mole
change in the
fraction,
total moles. Yes.
yeah, so now mole fraction would be 0.714 divided by 97.144. This would be 0.00735, right? So now you see
Yes,
it
sir.
is not.
What is Yes, sir. Actually, I realized this, sir. When I was saying checking, I was doing this, sir. There isn't a significant change from the answer which I got previously and this, sir, using this because before I used 7.14 into 10 power minus 3. Now it is 7.35 into 10 power minus 3.
Okay, so earlier you had.
Sir, the error is about of 3%. So
Yeah, so
can we neglect that or
yeah,
not
yes,
is the question.
yeah, yeah.
Ah, yes, sir.
So earlier you had 0.00714. That means error is 0.00021 out of 0.00714 into 100 percentage error, and our area is always on the job, divided by 0.00714 into 100. Error is about 3%. Okay, now 3% error is perfectly acceptable. Only thing is, only thing is,
The concept
suppose,
still.
suppose, suppose instead of talking about air and water vapor, suppose this mole fraction of some other situation, suppose this mole fraction was something like 0.5. Now it would make a significant difference,
Yes, sir.
right?
Yes, sir.
So now because it was air and water vapor, and fortunately in this particular case, it is a very small error because you are talking about only 3.57 moles out of the
Out of 100.
100 moles. So therefore the error is insignificant, but we should not be multiplying by mole fractions. We should be doing based on moles, material balances. We should be doing based on kgs and moles, not mole fractions, because mole fractions will not remain the same. Mole fractions will change because one of the components is changing,
Understood, sir. Yes, sir.
right? Okay, so now
Yes.
this is the correct mole fraction. See, otherwise in the morning I would have told you something and that error would have remained. So now
Understood,
this
sir. Yes,
this
sir.
is the correct point. Okay, okay, now go ahead. Now how?
Sir,
Yes.
sir, sir, I got the answer as
No, no,
Prajot's method,
forget about answer.
but I
For,
didn't use the basis.
forget about
I,
answer. Forget
I
about
calc
answer. Forget about answer. Let me complete. Forget about answer. Okay. Let Aniruddha explain his method. Maybe some other people also have used his method. They will also, we will all benefit from the discussion. We are not worried about the answer. And if you have got the answer without a basis, that is not actually correct. Unknowingly, you have taken some basis. So try to
yes,
Yes,
sir,
figure
sir.
out.
but not stated
Sir,
with
actually, without taking a basis, if you use the same mole fractions, indirectly you've taken the basis as 1 gram per
Correct,
or 1 gram mole.
correct, correct. So Praveen, it is not important whether you write the basis or you don't write the basis. It is not an HSC exam or an SSC exam where 1 mark will be there for writing the basis, and therefore we will be worried about that 1 mark. It is not about what you write. It is not about what you don't write. It is about whether internally in our minds have we taken, unconsciously have we taken a basis. Let us realize that unconsciously we have done some calculations, and unconsciously those calculations are based on something. That is your basis, whether you write it or you don't write it. That is immaterial. Praveen,
okay, sir.
am I
Yes, sir.
are you clear what I'm trying to say?
Yes, sir.
Okay, now Aniruddha, let us go forward. How do you get the answer total pressure from here?
Yes, sir. So because the relative humidity is the same, when you use that formula again, you
Now
the
wait, wait,
partial
wait,
pressure.
wait,
Yes,
wait. Relative humidity is same where? Now are you saying after compression also percent RH will be 75?
sir, I assumed that it would be 75.
No,
So,
that is not correct. Because
but the
remember
partial
what,
pressure will remain the same, sir.
let me complete, let me complete. What we are trying to say is that now if this was the air, we are having, let's say, piston, we are compressing this piston, temperature is remaining the same. Now liquid water is going to form. Now liquid water has formed, that means this air that is remaining, that will be 100% saturated. That means this air after compression will have 100% RH. Air, water is condensing out from that air. So the remaining air will hold maximum possible amount of water vapor. That means it will be 100% saturated. It will have 100% RA. That means partial pressure of water vapor must be equal to vapor pressure of water at the temperature we are holding constant, which is at 32 degrees centigrade. Is that clear, Aniruddha?
Yes, sir. Understood, sir. Yes, sir.
So percent humidity is not going to remain same, because earlier it was only 75%. Now that water has started to condense out of it, the remaining air that is here, it will be fully saturated with water vapor. Why? Because only then water is condensing out in the liquid form.
Yes,
So this
understood, sir.
remaining air will have 100% RH. That means the partial pressure remaining now is going to be equal to vapor pressure. And vapor pressure of water, we have seen how much was that vapor pressure of water. Let's go up,
35.5.
35.5. Right. So vapor pressure was 35.5. All right. So now our partial pressure in this air after compression is going to be equal to vapor pressure at 32 degrees centigrade, which is 35.5 mm Hg. Now what is the partial pressure? It is the mole fraction of water vapor multiplied by the total pressure. What is the mole fraction now? 0.00735 multiplied by total pressure must be equal to 35.5 mm Hg. So total pressure is going to be 35.5 divided by 0.00735. This is 48
4823.
4830 mmHg, right? So 4830 mmHg, if I divide by 760, this would become same as 6.36 atmospheres. Is that okay? Anybody has any doubts?
Understood, sir.
Yeah, thank you, Anil. Anybody, any other doubts?
No, sir. Thank you, sir.
Yeah, anybody else has any other doubts? Anil, the morning your voice was nice and loud and clear. Somehow now it is not very loud and clear.
Yes, sir. My internet is going on and off.
Oh,
So,
okay, okay. Anybody has any other doubts? Can we go to the next problem? If anybody has a doubt, please unmute yourself and ask. Otherwise, we'll go to the next problem. So next problem, let us just try to practice some of these calculations in a more, so that all these concepts are firmly registered in our mind. Let us say ambient air. Let's take 2 3 problems. So first problem, ambient air. Ambient air has temperature of, let's say, 40 degrees centigrade. Total pressure is 755 mmHg. Percent RH is, let's say, 65. Okay. I want you to calculate a couple of things. One, I would like you to calculate what is the humidity in kgs of water vapor per kg of dry air. That is the first thing I would like you to calculate. Second thing I would like you to calculate what is the dew point temperature, meaning pressure is constant, only temperature is reduced till we get condensation, start of condensation. One drop of water appears, that is called as dew point. Okay, I want that in degrees centigrade. That is the second thing I want you to calculate. Third thing I want you to calculate is kgs or grams of water vapor per meter cube of ambient air. Okay, there is a third thing I want you to calculate. So that is first problem. Second problem I want you to do is, let's say there is an ambient air with temperature equal to, let's say, 35 degrees centigrade. Dew point, when I say dew point, it is dew point temperature is let's say 22 degrees centigrade. Total pressure of course is now, let's say, 766 mmHg, just so that we have some different things to calculate. First thing I would like you to calculate is what is the humidity in terms of kgs of water vapor per kg of dry air. Second thing I would like you to calculate is percent RH. Third thing I would like you to calculate is again same thing, now slightly different, grams of water vapor per meter cube of dry air. Okay, they are different. First one I want per meter cube of ambient air. Second one I want per meter cube of dry air. So they are different. Okay, let's do these two problems. Let's do these two problems. Just so that we have enough practice of doing these kinds of calculations over and over again. Antoine equation I have given you in the morning. You must have noted that down in your calculations. If anybody has any doubts while you are solving, please ask. Unmute yourself and ask. Maybe some of you can do the first one. Some of you can start with the second one.
So, in
Yeah.
the Antoine equation for a
Yes.
log for any logarithmic function, what should be the significant digits that we should consider?
It is based on percentage, no? So it is, if your vapor pressure is, let's say, 25, you may, and if you are writing it, or if it is 25.1, you are rounding up to 25, you are making an error of zero point 0.1 in 25. So you are making an error of 0.4%. The same concept.
So no, as in like if I'm taking the exponent, then how much should I consider? Like
Uh,
again, 0.1%.
So no, so it makes a difference now. So if you are taking um, uh, e raised to 0.35, or let's say you are writing e raised to 0.25 and e raised to 0.251, what is the answer? What is the difference? E raised to 0.25,
E raised to 0.25 is 1.284,
1.284, and
and
e raised to
251 is 1.285.
1.285. Now imagine that if it was, let's say, 3.25, and now you are rounding it off to, let's say, 3.26. Now what is the difference? So for exponential it makes slight bit of difference.
3.25 is 25.790,
uh,
and 26.049.
so you see, now you are making an error of 4%. You're still three significant digits,
Yes, sir. Understood.
right? So it, for exponents, for exponential function it makes a difference because the inherent nature of the function.
Understood, sir.
Yeah. Some of you can start with the first problem, some of you can start with the second problem. And I need volunteers who would want to volunteer their answer. Rather than me calling out, somebody would like to volunteer, somebody who has not spoken right from start of the class, start of the semester, perhaps start of the year. Ruchita. Ruchita, I have not heard.
Yes, sir.
Would you like to volunteer with the answers? Tell us how to
Yeah,
calculate.
yeah, I'm solving the first question.
Okay. So you are going to be our volunteer.
Yes, sir.
Arya, till how long can we continue?
So till 2:30
Okay.
or 2:45,
Yeah. So we'll try,
that
at
would be.
least try to finish one problem so that we can discuss that solution. And Ruchita, then why not try second problem first?
All right, I'll see.
Sir, can I tell the answer of the first one?
Well, answer doesn't matter. I don't know. We'll have to ask Ruchita.
Okay, sir.
So you can tell your answer to Ruchita directly rather than involving me in between. And she can check if your answer is right or wrong. One second. Somebody. Okay, ready with the answers? Ruchita?
I'm still solving, sir.
Solve, solve. Anytime you are stuck, you can just tell me.
Sir, I have a doubt.
Yeah,
Sir, after the dew point, will vapor pressure be equal to the partial pressure?
after dew point means below dew point.
Uh,
Above dew point or below dew point?
About dew point?
Above dew point is like our
No,
previous.
sorry, below dew point.
Below dew point, below dew point, look at our calculations, what we were doing. Below our dew point, what happens? Water starts condensing, and as it becomes 100% saturated, saturation becomes 100%. So the partial pressure will become equal to vapor pressure, and vapor pressure reduces, therefore partial pressure also has to reduce. That's why water will start condensing out. The maximum amount of water vapor that can be accommodated in the air is based on vapor pressure. Vapor
Okay, sir.
pressure is the maximum amount of water vapor that can be accommodated in the air at the temperature of that air. Therefore,
And
after condensation, it will become 100% saturated. Partial pressure will always be equal to vapor pressure. Yes.
and sir, what about exactly at the dew point?
Exactly at the dew point, they are exactly equal.
Okay, so
That's the
thank
time
you.
when one drop of water condenses. That's what we call as dew point. Okay, Amrapali?
Yes, sir, thank you.
Yeah. No, no, not thank you. Thank you because you asked a doubt. Other people who did not ask, their doubt will automatically get answered.
So for the dew point, we have to calculate the vapor pressure, right?
I have no
Like,
idea. Now you calculate. We have done this problem. Morning, we found the dew point.
yeah, okay.
Okay. Now you are going to tell us how to solve. Are you ready with any one answer? Would you like to share that?
Yeah, I calculated the humidity. It came out to be 0.031.
That is the first problem or second problem?
The first problem.
Okay. This is 0.031.
Yeah.
Okay. Praveen, is that what you are going to tell? Answer that you are going to tell?
Yes, sir.
Yes,
I
sir.
do got the
Yes,
same
sir.
answer.
Yes, sir.
0.0311.
Okay.
Yes, sir. Even I got the same answer.
Okay. Okay, go ahead.
So for grams of water vapor per meter cube of ambient air, I'm
Hmm.
getting 33.011, and the dew point is 32.3 degrees Celsius.
So, dew point is coming out to be 32.19 degrees Celsius, and gram of water vapor per meter cube is coming out to be 34.29.
Okay.
Yes, sir. The dew point is 32.16 and gram of water vapor per meter cube of ambient air is 34.
Ruchita, are these people right, wrong?
I'm still stuck on the dew point, sir.
Oh, okay, okay,
Sir, dew point is 32.19, sir.
okay,
And sir, gram of water per meter cube ambient air is 32.63.
okay. I have no idea about the answers. Yeah, Ruchita has to tell us whether answers are right or wrong. Ruchita, look at our previous problem. If you are stuck, how did we find the dew point in the morning?
Yeah, sir, I'm looking at that.
Oh, okay, okay. I'll just put it up in the screen just for your.
Yeah, so the temperature is coming around 32.2
Okay.
degree.
Now, third part you can do. Anybody has done the second problem?
So for the second problem, the relative humidity is 100%.
How is that possible? Then dew point would have been 35 degrees centigrade.
Oh
So it
yeah, sorry sir,
is,
my mistake. My
Yeah,
mistake.
no problem.
so humidity is 46.75%.
Yes, sir. When I got 46.7.
Learn to round off. 3 or 4 significant digits is more than enough.
Hello, sir.
Yeah.
Yeah, got the third one as 34 point something. 34.29.
Okay, 34.3. So 34.29 is 34.3. Okay.
Yeah.
Would you like to tell us how you got this third answer?
So we have four. I took the basis as 100 grammars. So we'll have 4.7 grammars of H2O.
Wait. So let me write. Right. So uh, basis you have taken as 100 gram moles of,
Air.
okay, ambient air. Okay. So then
Yeah.
what?
I got the mole fraction of H2O as 0.047.
So how did you get the mole fraction? You got it from here.
Yes.
So at temperature of 40 degrees centigrade, what was the vapor pressure?
54.75.
54.75 mmHg. And
Yes.
if vapor pressure is 54.75 and relative humidity is 65%, that means partial pressure would be 65% of 54.75. How
Yeah.
much is that?
35.58.
30
5.58.
35.58 mmHg. So mole fraction of water vapor in the air would be 35.58
Divided.
divided by total pressure, that is 755. How much is that?
0.047.
0.047. So out of this 100 gram moles of ambient air, you are saying that you are having 4.7 gram moles of water vapor,
Yeah.
and dry air is 95.3 gram
Hmm.
moles. Am I right? Is that what you've done?
Yes. Yes. Yes.
Okay, now tell me further.
Now, 4.7 into 18 would be the weight of water vapor.
Right, so 4 point, how much is that? 4.7 into 18.
84.6.
Okay, 84.6 grams of water vapor.
Yeah.
Okay,
And then we find volume by the ideal gas law equation.
tell me how you got.
PV equals to nRT, sir.
Okay, so PV is equal to nRT. Okay, now tell me.
Yeah. 0.95 moles into 8.314 into 313.
0.95 moles. Which is 0.95 moles?
Oh, sorry, sir. Sorry. 95, 95.3, the dry air one.
No, I am asking you meter cube of
Yes.
ambient air.
Yeah.
Here I am asking you dry air.
Oh,
So,
sorry.
so
Huh.
don't you have to find out volume corresponding to this 100 gram moles,
Huh.
isn't it?
Yes, sir.
So pressure is 755 mmHg. So pressure is 755 divided by 760 into
Hmm.
1.0133 into 10 raised to 5 pascals.
Yes.
Volume is what we want to find out. R we can take as
8.
8.314 joules per gram mole Kelvin. Okay. Temperature is 40 degrees centigrade. So that is 313.15 Kelvin. So now volume would be nRT divided by P. N number of moles is now 100
It's
gram
100.
moles.
Yeah.
R is 8.314 joules per gram mole. Temperature is 313.15 Kelvin divided by pressure. Pressure is 755 divided by 760 into 1.0133 into 10 raised to 5 Pascal. So now this gram mole will get cancelled out. Oops, I should write joules per gram mole Kelvin, that is the unit of R. Now Kelvin would get cancelled out, and then joules is nothing but Newton per meter square into meter cube. Pascal, it is Newton per meter square. So this we will get volume in terms of meter cube. Okay, so 100 gram moles. Do this multiplication: 100 into 8.314 into 313.15 divided by 755 by 760 divided by 1.0133 into 10 raised to 5. So this is 2.59 meter cube. Is that what you get, Ruchita? Is that what you are getting by your calculations?
2.37, I guess.
4.37. How did you get that?
2 point.
2.37. How did you get that? 100 multiplied by 8.314 multiplied by 313.15.
Oh, sorry. It's 2.59.
2.59 meter cube. So when I take 2.59 meter cube of the ambient air, water vapor in that is 84.6 grams. So grams of water vapor per meter cube of ambient air is 84.6 divided by 2.59. This would be equal to 32.7, 32.66 or 32.7 we can say. All right. Is that okay?
Yeah, sir.
Okay, so now all of you should be able to do the second problem. I will just give you one more problem and then we can stop for the day. So we will not solve just now. I will just give you the problem. You try solving it. So let's say there is ambient air. Okay. This ambient air we are taking and we are heating that ambient air. So ambient air, let's say total pressure is say 740 mmHg. Temperature is let's say 45 degrees centigrade. Percent RH, or let's not say percent RH. Let's say dew point is let's say 35 degrees centigrade. Okay, we will heat. Okay, let's assume that this is isobaric heating. So total pressure remains the same. We want to heat it up to let's say 80 degrees centigrade. Maybe this air we are using for drying something, hot air. Is that okay? I want you to find out different things. I want you to find out percent RH here. I wanted to find out humidity here. Humidity, again, recall humidity is kgs of water vapor per kg of dry air. Right, these two things I would like you to find out. It is the same thing as this second problem, only thing values are different. I would like you to find out percent RH here. I would like you to find out the humidity here in terms of kgs of water vapor per kg of dry air. Okay, there is a third problem I would like you to do. Fourth problem I would like you to do is, let's say I have a mixture of nitrogen and methanol, okay, in the vapor phase, or a gaseous mixture of nitrogen and methanol. Okay, this is at a temperature of, let's say 70 degrees centigrade. Okay, kgs, or let's not say 70, let's say 60 degrees centigrade. Kgs of methanol per kg of nitrogen is, let's say, 0.5. Okay, now total pressure. Okay, total pressure also, let me give you total pressure. Let's assume that total pressure is 760 mmHg, 1 atmosphere. Now let's do isobaric cooling. So total pressure remains 760 mmHg. Okay. I would like you to find out the temperature to which I should cool. So if I start cooling now, methanol will start condensing out, like just like we had water vapor condensing out here. Just like we had water vapor condensing out here, now methanol will start condensing out. Okay, these kinds of things we do when we start doing dryers. So we'll do some examples like this, but just the problem before that. So liquid methanol will start condensing out. Okay, I would like you to find out the temperature to which I should cool so that 90% of methanol in the incoming gas is liquefied. Right? So that's how we would separate volatile components from non-volatile components. Okay.
So we'll have to use the same Anton equation.
So I'm just coming to that. Obviously, now the Antoine constants will be different. So Antoine constants of methanol. Remember what I talked to you about morning. First part of the lecture that we did when we were talking about basic concepts. These constants A, B, C are for a particular substance. So the constants that we have used, they are for water. Now the substance is different. Now the substance that is condensing or vaporizing is methanol. So Antoine constants for methanol are going to be different now. Use Google to find Antoine constants of methanol. Okay, and then solve this problem. All right, so you have to do this second problem, third problem, and fourth problem. So that's your homework. We will stop here for the day. Is that okay? Arya, is that okay? We'll stop for the day.
Yes, sir.
So you have other things to do. So we will meet on Thursday as usual. and Thursday as usual 10:30, and then we'll take it from there. All right.
So on Thursday also, will there be an afternoon class?
Yeah, I would like to have, because these things take time. These kinds of calculations take time. But you see your other schedule. Otherwise, Saturday we can have.
Okay, sir. I'll let you know.
Yeah,
Yeah.
we'll be in touch. Okay, so let me stop the recording. And of course, both these lectures I will